Now we want to look at a delta theta by delta r region. Okay, what do we mean by this? We're in polar coordinates. So that a delta theta region will be some region that makes, well, between two straight lines here, making a constant angle delta theta. So this angle here is delta theta. And a delta theta by delta r region within this delta theta increment is going to be, well, a delta r region looks like this. Okay, r in polar coordinates, of course, is your distance from the origin. A delta r region is a region between two values of r that are separated by delta r, just as a delta theta region is a region between two angles theta that differ by angle delta theta. Now if you combine the restriction that you're in a delta r region, which looks like this, with a delta theta region, which looks like this, you get a region as such. Now the question is, what is the area of that region? Well, here's a delta r by delta theta region. If delta r is the same up here as it is here, if it's this big, then here's a delta r by delta theta region. But this delta r by delta theta region is bigger than this one. Even if delta r is the same, this one has greater area than this one very clearly. Why is that? Because the delta theta increment spreads out as you move away from the origin. So the further you are from the origin, the bigger a delta r by delta theta region will be for a given value of delta r and delta theta. Okay, if you have the same values of delta r and delta theta here as you have here, this region will be bigger. Now why is it bigger? It's no wider in this direction, although maybe when I drew it, it came out just a little wider. But it excuse me, is longer in this direction because it's further from the axis and the delta theta region keeps spreading out. So to answer the question, what's the area, you got to know where it is. Specifically, you got to know how far it is from the origin. So that's what we're saying here. What's the area? You got to know where the region is. So suppose that we have a sample point within our region, a sample point r star theta star within our region. That means if this is our region, there's some point inside here that has coordinates r star and theta star, where r star is within the delta r restriction and theta star within the delta theta restriction for this interval. Okay, in that case the area is going to be what? Well, here's our delta r by delta theta region again, and we've got an r star theta star. The star in my theta seems to be kind of part of my parenthesis there, but I've got an r star theta star, some point inside here, which I'll kind of indicate by a little x. Okay, the delta r is what it is. The delta r is just the distance between these two concentric circles. The length of this side, though, or the arc here, depends on how far you are from the origin, so that the arc here will actually be a little smaller than the arc here. Now we're going to let delta r and delta theta shrink down, and we're going to shrink them past all bounds. We're going to let them approach zero, so that the distance in the arc here and here isn't ultimately going to be significant. And in fact, the distance of either of these arcs from the arc you have through the r star theta star point is going to be insignificant. So we're going to use the length of this arc to help us figure out the region of the area of this region, or at least the approximate area of this region. And the length of this arc is just going to be r star times delta theta. Okay, because your definition of a radian, your definition of arc length, the arc length out here is equal to the angle of the arc multiplied by the radius. Okay, so r star delta theta is going to be this dimension. And we also say that this is going to be very close to a rectangle. If delta r and delta theta are small, very small, you're not going to even notice the curvature here. And of course, we have a radial line in this direction, and we have an arc of the circle in this direction. They're going to be perpendicular. So this angle and this angle are going to be right angles, and so are this angle and this angle. Okay. Now, the one approximation we make is, instead of using the arc distance, we just use, well, we use the arc distance for what really should be a straight line distance from here to here. It should be clear that as delta theta gets very small, the length of that arc is very equal to just the distance between the 2 points. So that we have something very close to a rectangle whose area is then the product of r delta theta, this width, and the delta r, which we could think of as a length. So this is the region of the delta r by delta theta. This is, I'm not sure I said the right word, this is the area of the delta r by delta theta region. Okay, so when we're setting up integrals, we're going to want to describe regions in terms of r and theta, and that's what we're going to look at next. And if we're doing anything that requires us to talk about the area of small regions, as we've done in previous examples in XYZ space, we're going to be able to do that. So that's where we're heading. So we're going to do that in the next clip.